Good morning, afternoon, or evening, cats and dogs. Today's video is going to focus on the lesson 7.4 guided notes on subtracting linear expressions. This is the last lesson for Unit 4. Now, just like when we added linear expressions, I did start by using models to subtract linear expressions, and you can see these examples here. I don't want to spend a lot of time with the models just because I know that that's not something I'm going to ask you to do on a quiz or a test. And it gets to be pretty challenging with example 3 when we're subtracting and taking things away. So for example, I have negative 3x minus 2, which is negative 3x plus negative 2, minus 5x plus 3. So I represented the negative 3x plus negative 2. And remember the negatives, we use those shaded long skinny rectangles or squares right here. But if I have to take away 5x, the problem with that is I don't have 5 positive x's to take away. So you notice that I have to add 5 positive x's and 5 negative x's, so I'm not changing the problem itself. Cross off my 5 positive x's, which results in 1, 2, 3, 4, 5, 6, 7, 8 negative x's. So it's kind of weird the way you have to add something to take it away. So I don't want to spend a lot of time on that. I do that also with the 0 pairs here. But if you're really interested in seeing how this could potentially work visually, take a look at this because it's an interesting thing where you add 0 pairs into your algebraic expressions or your linear expressions here so that you can take things away. But I don't want to spend time with that because I know that, again, it's probably not the most important thing for you to see, given that you're not going to be asked to do that on a quiz or a test. But it is a very interesting problem that we have. So here's the deal. The one thing I really want to focus on with these guided notes is the rules for subtracting linear expressions because it's harder than adding linear expressions. So I'm going to highlight this box here where it tells us the basic rules that we need to follow as we go to, and I'd highlight that the whole way over, but that's my box there, and I don't want to stop the video at all, so the entire box should be highlighted. But our steps for subtracting linear expressions are going to be as follows. Recognize this as something as one big add the opposite. So just like when we changed subtracting problems like negative 5 minus 12 into negative 5 plus negative 12, we're doing a similar thing here with linear expressions. The very first thing I always do, though, is I add the opposite inside the parentheses first, just to make sure everything's addition and I don't miss any negative signs. And again, just like when we talked about simplifying expressions before, this is a really, 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 really important thing to do. So add the opposite inside the parentheses first. And then we do our massive add the opposite. We change our subtraction that's between the linear expressions to addition, kind of like we did here. And then I change all of the terms in the second expression, or the one that follows subtraction, to their opposites. So in this case, it's not just a single number, it's going to be an entire linear expression that we change to its opposite. And then it becomes one big addition problem, so you add the linear expressions just like we did before. Now, I will point out that I combine steps 2 and 3 together. I definitely do not combine 1 and 2 together, or 1, 2, and 3, but I do combine 2 and 3 together. So I change the subtraction to addition and each term in the second set of parentheses to its opposite in the same step, and I would encourage you to do that as well. All right, let's get right into our examples. So number 1, and there are some typed up for you as well. Feel free to look through those, but I think we can spend our time more efficiently looking through the examples that we need to do together. So number 1, 6x plus 8 minus 5x plus 12, subtracting those two linear expressions. Step 1 is to add the opposite inside the parentheses first. Well, I don't have any subtraction there, so I'm good with step 1. Check that off. Step 2 is going to be to change your subtraction sign between the parentheses to addition. And I'm going to do step 3 at the same time, which is to change each term in the second set of parentheses to its opposite. So positive 5x became negative 5x, and positive 12 became negative 12. So I added the opposite of everything in that second set of parentheses. It's like distributing the subtraction sign to both of those. Now, put your like terms side by side. That will be your 6x and your negative 5x, and then your two constants, 8 and negative 12. Let's combine those. 6x plus negative 5x is 1x. 8 plus negative 12 is negative 4. So I wrote this solution in 3 different ways. All are acceptable. 1x plus negative 4, x plus negative 4, x minus 4. I should have also included 1x minus 4 could also work as well. So any of those would be sufficient or correct. All right, number 2. Here we do need to do step 1. Add the opposite inside the parentheses. Negative 6x plus 11 stays the same, but negative x minus 9 is going to be rewritten as negative 1x plus negative 9. I do like to put that coefficient in there. Now, steps 2 and 3. Change subtraction to addition, and each term in the second set of parentheses to its opposite. Negative 1x becomes positive 1x. Negative 9 becomes positive 9. Now, let's put our like terms side by side. That'll be negative 6x plus 1x plus 11 plus 9. All right, combine those. What do we get? If you were thinking negative 5x plus 20, you've got it. All right, number 3. Feel free also to pause the video at any point and maybe try some of these on your own. I would wait for a few examples though until you feel a little bit more comfortable with this. Number 3, add the opposite inside the parentheses first. So negative 8a minus 4 becomes negative 8a plus negative 4. Now, steps 2 and 3, subtraction to addition, and each term in the second set of parentheses becomes its opposite, negative 5a to positive 5a, and positive 13 to negative 13. Put those like terms side by side, negative 8a plus 5a plus negative 4 plus negative 13. Let's combine them. Negative 8a plus 5a is negative 3a. Negative 4 plus negative 13 is negative 17. So my final solution is negative 3a minus 17, or negative 3a plus negative 17. All right, moving right along. Number 4, start off by adding the opposite inside that second set of parentheses. I also put a coefficient of 1 in front of both of the h's. So h minus 5 became 1h plus negative 5. Now, steps 2 and 3, subtraction to addition and distribute that subtraction to that second set of parentheses. So 1h becomes negative 1h, negative 5 becomes positive 5. Put those like terms side by side. We've got 1h plus negative 1h plus 5 plus 5. The h's cancel out. Do not write 1h because 1 plus negative 1 is 0h, which is gone. But we do need to do 5 plus 5 to get 10. All right, you didn't think you could get away with these problems without seeing some fractions and decimals. Let's see those. In number 5, add the opposite in that second set of parentheses to become negative 2/3 x plus negative 8. I forgot to change my parentheses to the big parentheses. No big deal. All right, steps 2 and 3. Subtraction to addition. Our negative 2/3 x is going to become positive 2/3 x. Let's get right here. And then our negative 8 is going to become positive 8 once we distribute that subtraction. All right, put your like terms side by side. We've got half x plus 2/3 x plus 3 plus 8. Final solution, if you're having trouble plugging anything into your calculator, please see me. I can help you with that. We should get 1 1/6 x plus 11 or 7/6 x plus 11. It looks a little cleaner to write it as an improper fraction, but both are correct. All right, number 6, let's add the opposite inside the parentheses. So the 2.8x minus 5.6 becomes 2.8x plus negative 5.6. Steps 2 and 3, here we go. Subtraction becomes addition. Positive 2.8 becomes negative 2.8x. Sorry, I forgot the x there. And then negative 5.6 becomes positive 5.6. Put those like terms side by side. Remember, as advanced students, if you feel like you can skip this step right here where you put your like terms side by side, that's okay too, as long as you're consistently getting the correct solution. So we're going to add 8.5x and negative 2.8x and 3.1 and 5.6 to get a final solution of 5.7x plus 8.7. All right, we've got 2 more of these simple problems before we see some word problems. Number 7, add the opposite inside the parentheses first. That's going to be negative 2x plus negative 9 and negative 4x plus negative 6. Steps 2 and 3, change subtraction to addition, and the negative 4x is going to become positive 4x. The negative 6 is going to become positive 6. Put those like terms side by side. That'll be negative 2x and 4x, negative 9 and 6. Final solution, 2x plus negative 3 or 2x minus 3. All right, number 8 asks us to find the difference of x plus 6 and negative 3x minus 4. So the first thing I did was I wrote the problem. Remember, difference means subtraction. I also added the opposite when I wrote it. That just made life a little bit easier for us. So I've got 1x plus 6 minus, in parentheses, negative 3x plus negative 4. Steps 2 and 3 means negative 3x is going to become positive 3x, and negative 4 is going to become positive 4. Let's add these bad boys together. We got 1x plus 3x and 6 plus 4. Final solution, 4x plus 10. All right, I do have some independent practice though first before we get to some word problems. So pause the video and give these two questions a try. All right, hopefully you've tried both of these problems and hopefully you did pretty well. Let's see. Number 1, you should get a solution of 2x plus 5. Add the opposite first inside those parentheses. Subtraction becomes addition. The 3x becomes a negative 3x. The negative 7 becomes positive 7. So 5x and negative 3x gets us 2x. And the negative 2 and the positive 7 become 5. All right, number 2. Hopefully you got negative 2x plus 11. Here's how we get that. Add the opposite inside that second set of parentheses. Subtraction to addition. Negative 2x becomes positive 2x. Negative 3 becomes positive 3. Combine your negative 4x and your 2x. Combine your 8 and your 3. Final answer is negative 2x plus 11. All right. Here we go with number 9. The number of customers in a store on the first day is represented by 7x minus 5. The number of customers on the second day is represented by x plus 6. Write an expression to find how many more customers visited the store on the first day. Then evaluate the expression if x is equal to 80. All right, so we're going to take 7x minus 5 minus x plus 6. Notice how when I wrote it down, I added the opposite. It makes sense to do that. All right, we're going to change subtraction to addition. Positive 1x becomes negative 1x. Positive 6 becomes negative 6. Now we add these. So 7x and negative 1x, negative 5 and negative 6 should get us 6x plus negative 11. We also need to evaluate the expression if x is equal to 80. So let's do 6 times 80 plus negative 11, which is 480 plus negative 11, or 469 more customers who visited the store on the first day. Now, a way you could check this is replace x with 80 in each of these expressions to figure out how many customers visited on each day, and then subtract them to see if you get 469, and you will. All right, let's go ahead and take a look at number 10. The expression 4.5x plus 3 represents the number of miles Julia rode her bike, and 2.5x minus 1.2 represents the number of miles that Angela rode her bike. Write an expression to find how many more miles Julia rode her bike in x hours. If they each rode for 3 hours, how many more miles did Julia ride? So it's very similar to the last one, except they don't say evaluate the expression if x is equal to 3, but that's what we're doing here. So we're going to take our 4.5x plus 3 minus the 2.5x plus negative 1.2 once I add the opposite. All right, change subtraction to addition. Positive 2.5x becomes negative 2.5x. Negative 1.2 becomes positive 1.2. 4.5x plus negative 2.5x is 2x. 3 and 1.2 together gets us 4.2. Now let's evaluate this when x is 3. So we're going to do 2 times 3, which is 6. 6 plus 4.2 is 10.2 miles difference. You will see questions like 9 and 10 on your test, I believe. I think there's a pretty similar question to this. The next couple of questions are a little bit higher level compared to what you'll see on your test, but I still think they're really good questions to help get you ready for algebra next year. So let's take a look at them. Then we have a couple of multiple choice problems to finish. All right, so number 11, it says the perimeter of the quadrilateral below is 18x plus 9 units. Find the length of the missing side. How would we do this? Let's add up what we know. We know 6x plus negative 4, 4x plus negative 2, and 6x. Let's see what we have all together. Well, we've got a 6x, a 4x, and a 6x, a negative 4, and a negative 2. So what we have is 16x plus negative 6. We need to get to 18x plus 9, our perimeter. So you could figure this out mentally, but we could also use subtraction. Take your perimeter, 18x plus 9. I'm going to slide this up, so we're going to lose that, minus what we have, which is 16x plus negative 6. So use our subtracting linear expressions rules. Subtraction becomes addition. Positive 16x to negative 16x. Negative 6 to positive 6. All right, 18x plus negative 16x is 2x. 9 plus 6 is 15. So what we need for that fourth side is 2x plus 15, which makes sense. Because if we need to get from 16x to 18x, you got to add 2x. If we want to get from negative 6 to positive 9, you've got to add 15. All right, let's try another one. Number 12, the perimeter of the triangle below is 20x plus 6. Find the length of the missing side. Well, let's start like we did the last one. Let's add what we know. 4x plus negative 2 and 8x plus 1. That's 4x plus 8x, which is 12x. Negative 2 plus 1, which is negative 1. But we need to get to 20x plus 6. Again, you might be able to do this without showing subtraction, but we'll take our perimeter, 20x plus 6, minus the 12x plus negative 1. Positive 12x becomes negative 12x, negative 1 becomes positive 1. 20x plus negative 12x is 8x, and 6 plus 1 is going to get us 7, which makes sense because if we want to get from 12x to 20x, we've got to add 8x. Negative 1 to 6, we've got to add 7. All right, couple of multiple choice problems. I add these in because honestly, multiple choice problems is where students struggle a lot. So number 13, it says, which simplified expression represents e minus f? So that's negative 7x plus 8 minus 3x plus negative 12. All right, change subtraction to addition. Positive 3x becomes negative 3x. Negative 12 becomes positive 12. Add negative 7x and negative 3x together. 8 and 12 together, we should get a solution of negative 10x plus 20. That is choice B. There we go. All right, number 14. So we've got to subtract negative 8x minus 9 and 3x minus 4. So for this one, add the opposite first. Very important. Subtraction to addition. Positive 3x to negative 3x. Negative 4 to positive 4. Add negative 8x and negative 3x. Add negative 9 and 4. We should get negative 11x plus negative 5, which is the same as negative 11x minus 5. We have to know equivalent forms, so that is choice C. All right, I know we went through that pretty quickly. You will be receiving an additional practice sheet on adding and subtracting linear expressions, which would not be a bad idea to try if you're looking for some more practice on this. Plus practice we see in class, practice you see on your review sheet, anything you can do to help get you ready for this next unit test, which is upcoming. Thanks for listening.